universe's history, you do have these philosophical arguments that seem to well substantiate the conclusion. You don't need to wait on physicists to come to certain conclusions, like there are no square circles.
Right.
You can reach conclusions about reality all on your own. But yeah, you do have some extra arguments that have come from cosmology lately, and the first development was right from Einstein and his gravity equations, general relativity. And what it says is that the way that the universe behaves is going to be governed by the stuff inside of it and the energy inside of it. And essentially, what the equations say is that the universe as a whole can expand or contract. It's actually highly improbable that it's perfectly static. In fact, that's why he introduced his cosmological constant, this highly fine-tuned thing to keep the whole thing static. And anyways, he shouldn't have assumed the universe was static. He called it his biggest blunder, letting his philosophy influence his science, because we came to find out that the universe, in fact, is expanding, just like his theory had predicted. And so we see the stars receding away from us and from each other. The universe really is expanding, just like his equations suggested that it was. And anyways, if you play that tape backwards, the equations tell you what happens, and it essentially ends in this point where everything has collapsed into a singularity or a nothing point. And right, so if you follow those implications of general relativity all the way to the beginning, you reach a singularity, which corresponds very nicely with the traditional theistic / Christian idea of creation from nothing. That's pretty much what we predicted, and a bunch of physicists and people went on record saying, "Holy smokes,
Yeah.
this seems to confirm theism." Because at the time, nobody even remotely expected a result like this. This is wild. You and I have grown used to the idea of the universe having a beginning, but before the 1900s, I mean, that was just mind-boggling to people, that the universe wasn't static. It was like seeing the sun reverse itself, kind of thing. So this was a unique prediction of the theistic community, really. And anyway, so we found out that everything traced backwards to a beginning. Holy smokes, what does that mean? These are gigantic implications, and that's a big part of where the Kalam was born, or at least that sort of reasoning. And right, there's quantum mechanics came on the scene as well, and we've found that at these very, very small levels, these quantum levels, things behave in ways that you wouldn't necessarily predict using general relativity. And so the point is that if you trace the universe's collapse down to that very small point, well, we're not quite sure what's going to happen. So I think you're not irrational for thinking that the predictions of general relativity will continue to hold. Okay, there's not a proof, but I'd say you're perfectly rational in making that extrapolation. And we can give examples of that in other areas of science where where there's a convergence of two fields, and the predictions of one dovetail nicely into the other. And that would be an example of what's going on here if general relativity continues to predict correctly to the very, very beginning. But as it happens, we also have some additional argumentation, thankfully, that say that for any expanding space, no matter what you say about quantum physics or those first moments, we have theorems, the Borde-Guth-Vilenkin theorem, that takes you right to the very beginning. It says, for any expanding space, there's a proof, as long as it's expanding on average throughout its history. That's the stipulation. Then it definitely has a beginning, and you can show that it contradicts the speed of light limit otherwise. Then you have another theorem that Aaron Wall put out that also is a kind of second law of thermodynamics type of argument. So in the background, by the way, another reason to think that the universe has a beginning is that stars are still burning, right? So from the second law of thermodynamics, the usable energy in the world is winding down, and that means if the universe were past infinite, we would have reached a state of heat death already.
Hmm.
Okay? The universe would be completely cold, isolated. Every particle would be who knows how far away from every other particle. And yet we're not in that situation. So that goes to show that the past bound is only a finite distance away. Well, this too has challenges. We're not quite sure what will hold at the quantum era. And so this is where Aaron Wall's theorem comes in, and it says, well, there's a generalized second law of thermodynamics that will apply even in the quantum situations. And once again, you reach the conclusion that there's a beginning, aside from like this highly contrived escape path where basically time reverses itself. If time reverses itself at the Big Bang point, then you have an escape route. But that's just not good.